Hello, and welcome to It's Time to Modernize Supply Chain Design. This is a special webcast brought to you by our friends at Avetta, Vertex, and Visible Supply Chain Management. My name is Bob Treblecock. I'm the Editorial Director of Supply Chain Management Review, and I'll be your moderator for this event. Joining me today is Milena Jankovic. Milena is a research scientist at the Megacity Logistics Lab at the MIT Center for Transportation and Logistics. She's also the co-author of an article on this topic in the January issue of Supply Chain Management Review. Before we get started, a few housekeeping items. If you haven't done so already, I'd like to remind you that attendees are invited to download today's presentation. We'll also have Milena's article in the resource box. Just click on the resource icon on your screen. Finally, remember that this is an interactive event. Feel free to submit questions as you listen to the webcast. Now, if we don't get to all of your questions, we'll forward them to Milena later. Now to today's webcast. The supply chain design and optimization methodologies most companies use were developed in the 1990s. The focus then was on the configuration of the network and the location of facilities. The goal was to minimize the costs of warehousing and transportation, and a new design was expected to last for a few years. In a business landscape marked by uncertainty, new business models, and shifting customer expectations, we have to ask, does that approach still work, or is it time to modernize supply chain design? Those are the questions Milena is going to answer in today's webinar. So Milena, without further ado, the microphone is yours.
Thank you, Bob, for the introduction, and thank you for organizing this webinar. I work at the MIT Center for Transportation and Logistics, and here we are basically working on a number of research projects in the field of supply chain design. But we also have a few dozens of corporate partners that collaborate with us on industry projects. And this basically gives us an opportunity to see what are some of the new challenges that the companies are seeing today, and how the existing methods that we have in research are able to basically address those challenges. And so this is going to be the topic of today's webinar: how can we basically leverage some of the new advances in research to design better supply chains? So let's first start with some of those new challenges that we see. So I think that this is something that probably everyone has already encountered. We have new business environments. Things have changed dramatically since the 1990s, when most of the methods of supply chain design have been developed. And how does that new business environment look like? Well, companies have global operations. They're present in multiple markets using multitude of sourcing partners. We also live in the era of Brexit, of trade wars, and just global economic and political instability and agitation. We have much more complex supply chain networks with a multitude of partners that have various types of relationships. And on the customer side, we also see a fragmentation of the demand, direct-to-consumer business, and multiplication of different distribution channels and sales channels with trends towards omni-channel retailing. And so in addition to that, we have shifting customers' expectations in terms of responsiveness, customization of the products, et cetera, et cetera. And the idea is that most of the traditional methods for supply chain design fail to capture some of the characteristics of this new business environment. However, we also see that in the last 3 decades, we have massive advances in different research areas that can be leveraged to basically design better processes. We can formulate a few requirements for the new science or the new field of supply chain design. And here are just 4 that seem to be the most important to me, and that we've been able to witness throughout the projects that we have made with companies that collaborate with us. And I will just list them here, and then I will go through each one of them individually and present you basically how do traditional methods address these challenges, why these do not work in today's environment, and what are some of the, let's say, potential lines of action that we can do today. So the first requirement would be to have supply chain designs that capture the complexity of global supply chains. So as you mentioned, supply chains are more and more complex, and traditional methods sometimes fail to capture that. A second requirement is to have basically a comprehensive approach, so where we're integrating within the same supply chain design, multiple distribution channels, and the supply chain all the way up until to the end consumer. The third requirement is supply chains that are capturing the uncertainty of the current business environment. So we've seen that we live in an era of global political and economic agitation, and we also have more and more uncertainty on demand and supply side. We need methods that are going to be able to capture that. And a fourth point, which in my opinion is maybe the most critical one, is supply chains that supply chain designs that capture the central role that supply chains have in corporate strategy. We will see later in the presentation that the role of the supply chains actually has evolved quite dramatically over the few years, and we need designs that capture that new role of the supply chains. So how about the opportunities that we have? To talk about the opportunities, we can first look at the side of the data, the methods, the quantitative methods we can put in place. Well, the first opportunity is really about the data and the data analytics. We have huge amounts of data that is readily available, often not used or underused. We have major advances in machine learning that can really help us to have a much more data-driven approach to supply chain design. We also have massive advances in computational power over the last 3 decades, and that basically allows us to build much better optimization and simulation models that are much more granular and capture the constraints of contemporary supply chains. And finally, another area of research that has massively evolved over the last, let's say, 15 to 10 years is network science. That basically looks at all the different types of network. This can be social network, biological network, or supply chain networks, and provides a completely new angle how to study these networks and to consider the individual parts of the networks. And I will give a few examples in the remainder of my presentation. So in addition to these, let's say, analytical methods and quantitative methods that you can put in place, we also see new opportunities that emerge with regards to the types of tools and frameworks that we can use to basically facilitate the decision-making process. Because at the end, supply chain design is a decision-making process, and all of those tools that we have mentioned are only supporting tools of that decision-making process. So here, the first element I want to highlight is interactive visualization. So as we have more and more data, and as the models that we are building are growing in complexity, this basically can lead to either what we call information overload, or basically lack of intuition about why something is happening and why certain results are produced by the model. And here, interactive visualization provides a much more intuitive interfaces towards those models and the underlying data. We also have what we call mixed initiative systems, where we are basically combining the power of the analytical models that run in the background and the implicit knowledge of expert decision makers. So we basically have humans and machines working together to design better solutions. And the last but not the least is we have huge advances in behavioral and cognitive sciences that basically allow us to formulate new decision-making frameworks for supply chain management. So we're thinking about how are actually people making decisions, what is the right type of collaboration, who should be involved, what style of collaboration is most effective to get to best designs, etc., etc. And so without further ado, I will go through these few challenges that we have formulated and these few requirements that we have formulated in the beginning of the presentation, and suggest a few new approaches that we can use in order to tackle them. So let's start with the first one, which is basically capturing the complexity of global supply chains. So first, we've already mentioned some drivers of complexity, for example, a large number of interconnected supply chain partners, but there are, of course, other drivers of complexity in today's environment. This can be increasingly large product portfolios, multiple markets with different taxes, labor costs, regulations, international trade with different tariffs, etc., etc. And to illustrate how we can tackle complexity of global supply chain with a very practical example, I'll refer here to one collaboration that MIT CTL had with a global chemical company. So this company had a network that was composed out of hundreds of logistics facilities. Some of them were owned by the company, others were 3PL facilities. They had tens of thousands of individual clients, a portfolio of thousands of different products, and all of those products had very diverse requirements with regards to storage, transportation, temperature control, etc., etc. And so their goal was to find a distribution network that minimizes the cost, but that also accounts for all of the different requirements of the product. And so what would be a traditional approach to this problem? So a traditional approach would be to have a sort of aggregate view of the network. For example, we would consider all of the products jointly, and we would probably aggregate demand information by country or by region and have very rough approximation with regards to the quantity of flows or, for example, the freight cost of different deliveries. And then we would run an optimization model where we have a limited number of constraints, for example, the capacity of the warehouses, and that would produce results that are not always capturing all the business specificities. Or we would have a simulation model where we are basically able to investigate a limited number of designs and would need to try one by one all the potential combinations of facilities that we want to consider. So what are some of the pitfalls of these traditional approaches? Well, the first one is very evident. This aggregate view of the network and these approximations actually lead to very inaccurate assumptions. So in the particular case of the company that I have mentioned here, we had errors that added up to around 60% of difference in freight costs. So if you use this as an input to our model, of course, we're going to come up with designs that are suboptimal. The second one is the lack of model realism. So given that we have so much constraints that are present with regards to different types of products, temperature condition, storage condition, et cetera, we are basically unable to capture everything in a single optimization model, and that leads us to a solution that is not the optimal one, but that is very approximate to the real business environment. And then a third one, well, if we want to actually consider all of those constraints and test them one by one, we end up with an information overload because we have to consider thousands of products, thousands of customers, and thousands of facilities. And so we basically need a better approach to this problem. I will here show you the approach that we took for this company and how we basically were able to leverage some of these new research advances in order to provide a solution that worked better for them. So the first thing that we did was to say, well, let's make sure that the assumptions that we are using in our different models are accurate. And here we made a freight cost prediction model using machine learning techniques. And we were basically able to identify a very large number of features that impact the cost of freight within the network. And so, of course, there are things like product characteristics, but we found, for example, that the quantity of deliveries, frequency of deliveries, and things like the direction of flow. So, for example, am I going from a large populated area towards a less populated area or the other way around? Well, that will actually have a huge impact on the freight cost. And so if you just assume that going from point A to point B or from point B or from point A costs the same, we'll end up with inaccurate model. And this first step basically allowed us to have much more accurate predictions on the freight cost at the level of each delivery item. So for every delivery item that we had, that this company had, for the thousands of products, we were able to say how much would it cost me that to transport that item from another facility using all of the different characteristics. The second thing we did was to basically try and restrict the number of candidate facilities that we want to consider for each particular product. So as I mentioned, we had thousands of products and hundreds of facilities. And if we want to consider all of the possible combinations, this is very hard. In order to do this, we used some elements of network science, where we basically isolated all of the products and all of the customer clusters relevant to those products, and then had an automated procedure that basically calculated a number of metrics that allow us to say what is the position of each warehouse with regards to that customer cluster. And that allowed us basically to identify the best potential locations for each cluster and each product among the hundreds of those that were available. And we did that through an automated procedure, and so this is something that is then very easily replicable and sustainable, maintainable on long term. And once we've done that, we had one final step, which is to produce a visual analytics tool. And so this visual analytics tool here contained a number of geospatial, abstract, aggregated visual representations, descriptive analytics, etc. And with this visual tool, users could do two things. The first one was to monitor the current network performance and basically identify, for example, those products or those customers that have a very high cost. And the second one was to test new network configurations. And here we basically used inputs from both the freight cost prediction model and the results of the network topology analysis that we did in previous slides. And this visual tool is interesting because it is here that users will be able to actually select the customers or select the warehouses and select the products that they know could best work well from a limited number of possibilities based on their local knowledge, based on their knowledge of the market and the product. And so we are basically doing a lot of work beforehand, but the final decision is taken by the user who has a better knowledge of all of the business constraints that need to be taken into account. So this was for the global operation. Now, when we look at the, let's say, other end of the spectrum and we look at what is happening closer to the end customer, well, we see also more complexity. What are some of the drivers of the complexity? Well, we have increasing fragmentation of shipments. This is partially driven by direct-to-consumer business, but not only. Multiplication of sales and distribution channels, and we also have rising service level expectations. So not only, for example, we have more and more direct-to-consumer business, But for the direct-of-consumer business, we will have, for example, multiple delivery services, next-day delivery, same-day deliveries, instant delivery. We'll have short delivery time windows, scheduled deliveries, etc., etc. And so these elements are typically not included in traditional supply chain design methods. Again, I will refer to one example, one project that we did in collaboration with a major Brazilian omnichannel retailer for their market in Sao Paulo. They had thousands of orders per day, and they basically had two distribution channels. So they had brick and mortar stores and online stores, sales, sorry. And these online sales were a combination, again, of direct sales and online marketplace, which added additional sources of complexity. And for the online sales and home deliveries, then they again had multiple delivery services, next day, same day, and instant deliveries. And the objective was to basically find a last mile distribution network this time that will minimize the cost across all of the different delivery services. So what would be some of the traditional approach to this problem? Well, typically we'll ignore synergies between the distribution channels, or we will consider them in a very qualitative way. We'll optimize for one, then for the other, and then try to find if there are some overlaps, but we'll not structurally consider them. Secondly, we will typically optimize for a single, most predominant delivery service, and then we'll kind of try to plug in the other services into that network. And we will have a sequential decision-making where we are first making decisions relevant to, for example, location of facilities, and then we're looking at things like, okay, what type of fleet should be deployed and how to perform routing on a daily basis. Well, a very common pitfall of this is that we come up with suboptimal solutions. So if we are optimizing only for the most predominant distribution channel delivery service, that can lead to important inefficiencies in the secondary channels or services. We also have large gaps between the expected and the achieved operational performance. So if we do not integrate, for example, fleet and routing choices within the network design, we will have very large gaps, for example, in the cost of those routes than what was initially planned. So in order to address this issue here, I'll show you a few things that we did for this Brazilian omnichannel retailer. So the first step was, again, data analytics, and here we are basically aiming to characterize last mile operations in a very, very granular way. So we are considering, for example, each distribution channel, each delivery service, each neighborhood, each type of transportation mode that can be deployed separately, and we are performing a very highly granular characterization of the operations. We're also characterizing neighborhoods with regards to their infrastructure properties, et cetera, and we are basically capturing all of the little details of last mile distribution that at the end have very big results on the cost of operations. The second thing that we did here was to basically produce a integrated network design model that combines multiple delivery channels and multiple delivery services. We are also integrating decisions relative to facility locations, to fleet, and to routing within the same model. And this is very important because, for example, if I choose to place my logistics facilities very close to the customer, I will probably incur additional cost of facilities because of the real estate costs, but this may be compensated by the cost, for example, in the routing of the deliveries in the distribution. And so it is important to consider both of those together before we design the model and to see where is the best trade-off between the two costs, for example. And we are also considering the different types of routes, so home delivery, stores, combined routes, et cetera, et cetera. And the result is this. The result is what we call a high-resolution last-mile distribution network design In this particular case, we came up with a three-tiered last mile network structure where we had basically 3 layers of facilities ranging from logistical hubs that are in the outskirts of the city to very local logistical facilities within the city center. And we have, for each type of service considered, so here we have standard, express, and instant deliveries, a different mix of transportation services according to the neighborhood in which we are operating. And so, for example, for standard deliveries, we will use vans and cargo bikes, and for the instant ones, we'll use motorbikes and crowd shipping. And we are looking for a solution that is basically optimizing and minimizing the costs across the board rather than for a single delivery service. A third point that I would like to discuss now is the uncertainty and the methods to basically capture uncertainty of the current business environment in supply chain design. So again, what are some of the drivers of uncertainty? Well, we have increasingly more sources of uncertainty at the demand side, shorter lead times, global operations, supply side, process side, with, for example, variable lead times. And we also have macroeconomic factors such as fluctuations in oil price or currency exchange rate that will impact all of those different dimensions of uncertainty. So to discuss uncertainty, I will again refer to an example of a project that we did for a major FMCG player in Colombia. So this player had a highly fragmented demand with tens of thousands of customers, millions of orders, very short delivery lead times, and variations in demand that occurred on daily basis. And so their goal was to design a distribution network that will both minimize the expected cost and the risk related to the uncertainty of the demand. Again, what is some traditional approach to this problem? So a traditional approach would be to say, well, let's take some average value, for example, average value of demand, and design a baseline network. And then let's run some sensitivity analysis, for example, what is the minimum maximum value of demand, and see, for example, what are the maximum capacity that we need to handle. And then once we come up with that range, we introduce flexibility measures in order to mitigate the effects of the uncertainty. Well, what we show in our research is that actually, if we are using this traditional approach, we are systematically arriving to a suboptimal design. So if we are only optimizing for a limited number of scenarios, average or maximum scenarios, we will have inefficiency in other scenarios. We also have less robust design with much larger variability in performance, and we have higher operational costs. And we actually show that if we only introduce flexibility after the design, that can actually lead to higher costs than if we do nothing. And so the project that we did here for the company is, again, in a few steps. So the first step is to basically identify the sources of uncertainty and flexibility. So in this case, this was the uncertainty of the demand, and you can see the demand distribution here, and two main sources of flexibility, which was facility capacity and transportation capacity. And we also perform a sampling of scenarios that we're going to use further on. And then what we produce is a stochastic network design model. And as you can see here on this tree, we actually have a tree that allows us to basically map all of the potential outcomes and to associate a probability to those outcomes. And we are kind of mapping all of the possible futures or all of the possible scenarios that can occur, and so this can be relevant to the demand, but it could also be relevant to many other things, for example, fluctuation in oil price. And then we're looking for a design that is optimizing not for one or two of those outcomes, but for all of those outcomes combined across the board. And when we do that, what do we get? Well, we get more robust designs. So in this case, we had minus 38% of variation, and designs that are yielding lower operational costs. So here we had 6% of cost savings with 38% of risk decrease. And now the last point, which I think is maybe the most central element of the presentation that I would like to discuss today, it is actually about the role of the supply chains and the role that they are playing today in the overall corporate strategy. So in this new environment with increased uncertainty, global operations, et cetera, what we see is that the supply chains are basically becoming major drivers of competitive advantage. And we can think of many ways in which supply chains impact the competitive advantage of company. The first one is, for example, where do we deploy our assets? How do we develop our supply chain to enter new markets? How do we deploy supply chain to meet the customer's expectations and therefore grow demand? How do we design the postponement strategies within supply chain to address mass customization? How do we respond to changes in demand, integrate sustainability concerns, et cetera, et cetera? And so we can no longer think of supply chains as an element in company that has a subservient role to, let's say, overall corporate strategy, but actually it is an element that it will drive to a great extent corporate strategy. And so to illustrate this, let's look at one example of a project. So this is a global manufacturer that wishes to redesign its US network. And so we know a few things here. So the first thing is that the closer they are to the customer, the higher the market share. So the proximity to the demand drives market share. However, the exact customer response in the new markets is yet unknown. So what we know also is that, well, if we increase the network of warehouses, we will basically increase the proximity to the demand and increase sales, but that will also involve additional costs. And so the objective here is to design a supply chain that drives market share, but also maintains logistics costs under the control. And so the supply chain design here is actually a driver of revenue, driver of market share, and their competitive advantage. And so what would be some traditional approach to this problem? As Bob, you've already mentioned this in your introduction, the focus would be on minimizing cost, on designing supply chains for operational efficiency. We will probably use some generic supply chain design solutions and handle studies within the supply chain and logistics department with a few interactions with other departments. And we would do this exercise every few years. The common pitfalls, I think they're quite self-evident. Well, we end up with designs that are suboptimal from the point of view of the overall business strategy. We're unable to capture the specificities of each company by these generic solutions. So if my supply chain is the basis of my corporate strategy and the basis of my competitive advantage, I need a supply chain design solution that is able to basically translate that. By ignoring the other stakeholders and other functions in a company, we are failing to incorporate some of the knowledge that they might have about the market, for example, and that can help in designing the supply chains. And we also end up with designs that typically lag behind the evolving market conditions if you have this infrequent process that takes place every few years. And so to illustrate a different approach, let's go back to the example of this global manufacturer. So what we did first is basically designed a model that integrates multiple measures of performance. So you see here we have a certain network configuration, and that network configuration is linked to a cost, market share, a sales, and many other measures of performance. We then made a visual analytics tool that allows them basically to have an aggregated view of performance of the different scenarios that we're considering along those multiple dimensions, and to kind of identify the trade-offs that can exist between those different objectives and dimensions. And we also elaborated and integrated into this network design model and the visual analytic tool a distance-based service model. So here we basically use a function that allows us to say what will be the share of the market share that I will be able to capture depending on the distance between a warehouse and a customer. And so we have done some work previously in order to elicit these demand functions from the company data, but from the parts of the market where this demand function was unknown, it was actually possible for the representatives of the company to play around with these demand functions and to see how they affect the overall design. And this brings us to the last point, and I think which is maybe the most important element of the supply chain process, which is to actually put in place and facilitate a cross-functional co-design process. So here we had members of logistics, finance, sales, and marketing department that all came here. So this is in the Cave Lab at MIT CTL. And this co-design process allowed those different stakeholders from different departments to, on the one hand, agree on what are the objectives of the supply chain design. So, for example, what is the relative importance of capturing more market share versus decreasing cost of operation, and also to elicit some of the knowledge that different departments had. So, for example, the representatives from marketing and sales department had a much more better understanding of the competitive pressure and the effectiveness of sales force in the different regions of the country, and that allowed to have a much better demand function and to kind of adjust that demand function to actually reflect their local knowledge. And so in this way, we are basically addressing not only uncertainty, but also some of the ambiguity that can exist in supply chain design, where we recognize that we can never comprehensively capture all of the business constraints in one single model, and that input from expert users can also be very, very valuable. And so this basically brings us to the end of the presentation. So I've given a few examples here, and we've seen that in each of those examples, in each of those 4 projects that I mentioned, we used a different combination of tools, visual analytics, interactive systems, different analytical methods, optimization, network science, machine learning, etc. And actually, when we talk about modernizing supply chain design, well, we believe that this has to happen across the board. So we need to think about the objectives of the design. So are we only minimizing for cost or integrating additional elements? We have to think about the design decisions that we are making. So is this only, for example, the structure of the network, or is it also, for example, outsourcing decisions, go-to-market decisions, et cetera, And once we have established that, then we can pick the right tools and the right methods that will support that process. But the starting point is really this: what are we trying to decide, and what are the objectives of the decision-making process? And I would say the overarching element to that is how do we actually design the process itself? So who are the stakeholders that we are including, how frequently are we performing the design, what is the planning horizon, what are the decision-making frameworks that we can help to facilitate and to help that design process. And depending on the way that we design this process, for example, on the stakeholders that we use, the underlying elements will, of course, be different. We'll have different objectives, different decisions, et cetera, et cetera. And so this is we really argue for a much more comprehensive approach to the field. And we also believe that given that every company is different, every company will have a very different combination of the objective decisions, tools, and methods that should be employed. So the idea is really to try and find the best combination that captures the most important decisions for each company and the specificities of the market in which it operates. And so this brings us to the end of my presentation, and I will take a few questions now. Thank you.
Thank you, Milena. And thank you, attendees, for visiting with the webinar. I hope you found it as informative as I did. I want to remind you that you can submit questions. If we don't get to all of them, we will email them to Milena afterwards, and she can respond back to you. Milena, I'd like to start with a couple of questions, really where you left off. The first is, we talked about these different business models and different criteria that are impacting supply chain designs. And you just made the point that every company is different. So I realize there's not going to be a one-size-fits-all. But in your interaction with your partners at MIT CTL, are you finding one sort of set of factors that's kind of ascendant? That is it, time to market or customer service? Is there something that's emerging as sort of a leading candidate there when people are doing the redesign versus the kind of things we looked at in the past, like minimizing the cost of warehousing and transportation?
Yeah, so I definitely think that the focus on the customer and thinking about supply chains from a customer-centric perspective is definitely something that we see across the board. And so, yes, we have usual considerations about cost of operation, et cetera, but companies now feel that it is really in the way that they are serving their customers that they can progress more. And we often see that actually some companies don't even know what the requirements of the clients are, and so in some cases it is actually really interesting to first start and understand, well, what is the sensitivity of my customers with regards to the delivery lead time? Is this something that has to be good enough, or is this something that will actually be a main driver of my competitive advantage? What is their sensitivity with regards to the prices, et cetera, And once we understand what are the main requirements from the customer side, then we can design this basically customer-centric supply chains.
Well, that's actually comforting to hear, because we've run a number of articles in our Supply Chain of the Future series about the customer-centric supply chain. So it's actually good to know that people are taking that to heart, and that's becoming a driver. A second thing I wanted to ask you, and this might be an observation more than a question, but you might want to respond briefly to it. I was listening to slide 32 when you talked about doing a design with a company where you brought in representation from the various stakeholders within the organization. And it sounded almost like an S&OP process for supply chain design. Do you liken it in it? Because I know MIT's done some things around S&OP as well. So do you liken it almost to, what happens in a good S&OP process?
That's actually a great observation, because when we think about a few elements of this new process that I've described, one of them was cross-functional process. The second one was higher frequency of updates, so going from maybe a few years to 6 months or something like that. Well, what we end up actually is S&OP process, and so this might be a good way to kind of connect these two. And it is also during that process that we are making links between the strategic and the tactical operational decisions. And so this is, again, something that we have highlighted as important. We should be able to, every 6 months or so, identify what are the new signals of the market, of the demand, what are the situation on our network, and basically adapt our network to respond quickly to those signals as we would do for other things in an SOP process. Yeah.
Great. We're going to have time for 2 more questions here. So one is, we talked a little bit, or you talked a little bit about global operations. You also talked a little bit about last mile delivery. And can we integrate both strategic, the global operations, and the operational, the last mile delivery, for instance? Can we integrate those into one single design process?
We can definitely integrate networks, global networks, with last mile distribution networks. We will, however, still have constraints with regards to essentially computational power of, for example, optimization models that we want to run. So it's unlikely that we are going to be able to integrate, for example, both the type of transportation and facilities that we run on a very global network with the last mile delivery to each individual customer. But what we can do, and that's something that we are actually actively working on, is to find ways to introduce interfaces between those 2 levels of design. And for example, a lot of the work that we do is about how can we approximate the costs of freight operations within one city using some, let's say, parameters with regards to its size or density, etc., and then use that approximation that is maybe 1 or 2% different than the actual operations, but still probably good enough for the global network design model. So there are definitely ways to integrate the two, but the more complex and the bigger the problem becomes, it generally means that we'll have to sacrifice a level of granularity somewhere and a level of precision somewhere. And there, I guess it's each company that has to decide what are the most important elements where they need to have the very precise estimation versus an approximate one.
Thank you for that. We're going to have time for one more question. And again, I'd like to remind attendees that if we didn't get to your questions, we will forward them on. So this is actually, I think, goes to the center in what you do. But you had some slides with screenshots of visual design models. So how can we develop those tools, or how do they get developed?
Yeah, so at CTL, so Center for Transportation Logistics, we have a number of researchers that work on various supply chain problems, and we also have a number of researchers working on supply chain design. And so we basically help companies throughout the whole process, trying to understand what their business needs are, analyzing their data, identifying what are some of the main inefficiencies, etc., and then trying to kind of formulate, okay, well, what is the type of model that you need, and then once we've done that, what is the type of decision-making tool that you need. And so all of the screenshots that you've seen here are actually apps that we have developed here in-house. We are generally using open source software that is available, and then once we have kind of come to the end of that process, well, company can either decide to continue using that basically prototype or take it to production with a company that will develop the commercial software based on it.
Great. Thank you. That's all the time we have today, but first I'd like to remind attendees that you can go to the resource area on your screen. You can download today's presentation. If you go to the last slide, you'll find contact info for Milena and also for the center at MIT. And you'll be able to download the article that she and her co-authors wrote about this topic if you want to learn a little bit more. So I'd like to again thank Milena for a great webinar today. I want to thank Avetta, Vertex, and Visible Supply Chain Management for its sponsorship and making this possible. For Supply Chain Management Review, I'm Bob Treblecock.